Good evening, everybody. Good evening. I am overwhelmed. My goodness. This is the biggest turnout I've ever seen in this lodge. It's got to be a record or something. Let me put this back in. I'm holding it. Thank you. Thank everybody for coming tonight. Thank you so much. This is really just overwhelming to me. A few people I would like to thank. First of all, John Allen, I'd like to thank for getting our guest speaker here tonight.
Thank you, Worship.
And arranging for everything. Thank you. I'd like to thank the Right Worshipful District Deputy Grand Master for coming here tonight. Thank you.
My pleasure, thank you.
The title?
Master Council.
The Master Counselor of DMLA is here tonight, Max Lennon. Nice to have you guys here tonight. Also would like to thank the people from the Lodge Committee that showed up here last Saturday to clean the lodge out and get everything ready to receive the visitors and just to get the lodge cleaned out. I appreciate everything. And Adrian, back there, Brother Wooster's girlfriend, thank you for coming and feeding the troops. That was very nice of you. Again, just make sure to check your cell phones. And without further ado, I want to get this program started. I wrote it down, so bear with me. I wanted to get this right. I'm extremely excited. I'm a huge Apollo fan, and everything I can see or read about Apollo or digest, I do. So, the Earth is approximately 4.5 billion years old. The most recent scientific studies place the origin of life here on Earth starting about 700 million years after that. After 3.8 billion years of life, a species arose on this planet that was capable of breaking the grip of its gravity, travel to another body in the solar system, and walk on its surface. 12 men accomplished this feat, supported by hundreds of thousands and viewed by hundreds of millions. I, for one, was lucky enough to bear witness to these events. Our guest speaker tonight is a Life Scout in the Boy Scouts of America. He was also a member of DMLA International and has been inducted into the DMLA Hall of Fame. He is a pilot, engineer, astronaut. He traveled to the moon as part of the crew of Apollo 14 commanded by Alan Shepard. As the pilot of the lunar module of Apollo 14, he maneuvered the LEM down to the surface of the moon and landed it there on February 5th, 1971. Soon after that, he then exited the craft and became the sixth person ever to walk on the moon. There he spent 9 hours working on the lunar surface in the Fra Mauro Highlands region. After 33 hours and 31 minutes on the lunar surface, he then departed the moon and rendezvoused with Command Module in lunar orbit, piloted by Stuart Roosa. The three men returned safely back to Earth on February 9th, 1971. You have heard the phrase, 1 in a million. Well, if there are 6.8 billion people living on Earth right now, our guest tonight is 1 in 566 million. Brothers and guests, it is my privilege to introduce Boynton Lodge's guest speaker for tonight, a brother of the Masonic fraternity and a true American hero, Dr. Edgar Mitchell.
Thank you very much. Thank you all. Thank you. 1, 2, 3. We haven't got this working yet. Where's the switch? I can't see it.
Let's see here, Doctor. Says on.
I don't think so.
A little light.
Here we go. 1, 2, 3. 1, 2, 3. Nope.
Take it off mute. You want to help us with that?
Pardon?
Says mute.
Push.
Mute. There you go. Try that.
1, 2, 3. 1, 2, 3. Oh, good. All right. Thank
Want to
you.
place it with me, or?
No, that's right. I'm going to step right down here.
I'll stop. Get your water.
Well, maybe I'll get something, but I'm okay. Well, if you want to look over at the screen and the picture of Earth as taken from about halfway back from the moon, that particular picture was taken on Apollo 10. Now, Apollo 10, I was backup crew on that to Gene Cernan. And we only have a few of those pictures. There were only 2 missions to the moon that could get that sort of picture. because we had to launch at a different phase, so none of us could see Earth in its full phase like that could see it. We had to launch at a different time. Only the guys that didn't have to land on the moon could take pictures like that. So we all use that one. That's one of the most beautiful pictures of Earth that you'll ever find. And I have been involved in, I'll tell you a little bit about my story before I start into the presentation. I've been involved in this since the late 50s. You'll see some slides on this in a minute, but I was coming back from the Korean War aboard an aircraft carrier in October of 1957, when Sputnik was the first spacecraft, unmanned spacecraft, to go to the heavens. And I realized at that point in time that we humans had just entered a new phase of existence. We had just gone into space for the first time. And I realized that humans would be right behind robot spacecraft, and I wanted to be a part of it. So my career path changed on October the 4th, 1957, with the launch of Sputnik. And the result is history. We'll talk a little bit more about as we go on. But the program I'm going to show you tonight, if this thing works from this distance, we'll see. Looks like I'm going to have to walk over a little closer. There we go. That one worked. Okay, I call this program One Path to the Moon, namely mine, the path I made to the moon. And we'll try to go on through here, and I'll show you a little bit of it. There we go. Now, that's where I started in 1934. My family were ranching people in New Mexico. And that was my first pet, my little Shetland pony named Sparky. And I was just 4 years old when I was riding him. And then I became, a few years later, interested in aviation because the Roswell Air Force Base was just right down the road from where we lived. And I wanted to start flying, so I started flying in 1943 when I was 13 years old. And that was kind of the beginning of all of this. And when I finished high school, I lived in Artesia, New Mexico, which is right down the road from Roswell, New Mexico. You may know that name because Roswell and Artesia were in the Pecos Valley on the east side of New Mexico. And there's been some interesting stories that were from that part of the world in 1947, as a matter of fact. And they're starting to get a little attention right now. I went off to an Eastern college, Carnegie Institute of Technology in Pittsburgh, and got a degree in industrial management, which is what I thought I was going to do. But it turns out that the Korean War was on at that point. Whoop. The Korean War was on, and the draft board said, "We want you," and so was the draft, by the way. And I said, "No, you really don't want me. If you want me, I'm going to enlist so I can fly." So I enlisted in the Navy, went to boot camp in San Diego, then went to officer school, got a commission, then went to flight school, and ended up then in Navy flight training, Pensacola in 1953. We keep ending up with years and ending in 3 here. It's just every 10 years or so something new was happening. And that was the beginning of my flight training in Pensacola, here in Florida, in 1953. And of course, at that point, carrier training, since I was in the Navy, we had to do carrier training. And this is an old SNJ, one of the early training birds at that period. Some of you gentlemen that are aviators have been, if you were in the Air Force, you'd call them AT-6s. In the Navy, we called them SNJs. And went off, after I finished that, went off to sea. And as I said, in 1957, I was coming back home aboard an aircraft carrier. The Korean War had already ended, and I was coming back to test pilot duty. And that aircraft you see there is an A-3D. It's a heavy bomber, for an aircraft carrier, one of the big aircraft carriers back in that time in history. And I was coming back to test pilot duty and I was at the Naval Test Facility in China Lake, California, which if you probably don't know where that is, it's just north of where Edwards Air Force Base is in California. And I was there on test pilot duty. And I realized while I was there, well, the first astronauts were just being selected when I was there at China Lake. And I was about 5 years younger than the first guys, Alan Shepard and Gordon Cooper, and all who later became my buddies, and Alan became my teammate on Apollo 14. But I realized if I was going to catch up, that I'd probably need a little more education than I had in a different direction. So I went back to school. I had some time coming, and I went back to school, went off to graduate school at MIT and got a doctor's degree. And at that point in time, just to bring you up to a little speed in history, some of you were around there at that point. At the beginning of the space age, President Eisenhower established NASA, and one of the first things that NASA did was to get some of the universities involved. And let me remind you, those of you who are a bit older, our knowledge of the heavens in 1957 and 58, right at the beginning of the space program, was about as sophisticated as God in the heavens, man in the middle, and everything else below. We really didn't know what was out there. And okay, some astronomers had some pretty good pictures and had some pretty good telescopes, but we really didn't know what was in the heavens. And what NASA did at that point was have the major technical institutes in the United States, MIT, Princeton, Caltech, and Princeton, Caltech, MIT, and set up graduate programs so we could at least have somebody that's starting to try to know and understand what's going on out there in terms of manned spaceflight. And I was fortunate enough, I was one of the first people to get to go through the program at MIT and get a doctor's degree in it in 1964. After that, I went on back to do some duty at Edwards Air Force Base and did some space pilot training there. And I was teaching at Edwards optimization theory because of my graduate work, but I was getting to fly hot aircraft like the F-104 up into the edge of space, and so that was the beginning of my training in spaceflight. And I was selected there in 1966 in the group of astronauts, 19 of us that were selected at that point as the ones that were primarily oriented toward going to the moon in the Apollo program. And as we were all selected, and in those days, since we really didn't know whether, when we came back from the moon or came back into the Apollo spacecraft, whether we were going to land right where we wanted to, we had to go through survival training. And we had to go through survival training in the jungles, and training at sea, and in the desert to survive for up to a week on the equipment in the Apollo spacecraft in case they took that long to find us. So that was just a part of the program back in those days. And then I was selected in 1969 for crew status on Apollo 14. Now it's a little longer story than that. I will tell you just a little bit. Actually, my original flight was Apollo 13. How many saw the Apollo 13 movie? A lot of you. Well, Apollo 13 was my original flight because at that point in history, we served backup on a flight, and then 3 flights later, you could serve on a prime crew. Backup crew was considered a training mission. So I was on backup on Apollo 13 with Gordon Cooper. And that meant we would go to, rather on Apollo 10 with Gordon Cooper. And that meant we would go to Apollo 13 3 flights later. But Gordon wanted to retire at that point. He'd done enough. And he wanted to retire. And Alan Shepard, who was our first guy in space, had been grounded with Meniere's syndrome, and that's an inner ear problem that kind of threw you off balance. He got that fixed and was back on flight status and wanted to take over Gordon's position from Apollo 13, on Apollo 13. They allowed him to do that at NASA at Houston, but headquarters said, Alan, you haven't been training enough. Why don't you guys switch with Apollo 14 guys, and you take another few months of training, and let 14 take 13, you take 14. We didn't really want to do that, but the boss said so that's what we did. And they got the bad machine, we got a good machine. And furthermore, you probably, if you saw the Apollo 13 movie, you know that Ken Mattingly, who was another one of our buddies on my group, along with Fred Hayes, who was lunar module pilot on Apollo 13, we were on the ground and in the simulators. We were the most advanced astronauts in our respective positions of command module pilot and lunar module pilot. I was a lunar module pilot. And so we spent the 4 days of Apollo 13 doing what they had to do in space to help bring them home. Before they could, we were in the simulators practicing doing what they were doing, or have to do, before they had to do it, and then radio up anything that we discovered. So, unfortunately, they're all back. They got back, and we helped save our buddies on that one. The Apollo 14 crew, as you may remember, myself on the right, Stuart Rusa in front on the left, and Alan Shepard, our commander, in the back. And give you the spread of things. Apollo 10, as I mentioned, that was a dress rehearsal for a lunar landing. All they did was, they went there, did everything but actually land on the moon. All the other operations they did. Apollo 11, their job was to prove we could land on the moon and get off safely. Apollo 12 was to prove we could land right where we wanted to land on the moon, grab a few rocks and get off safely and come home. Apollo 13, that didn't make it, and we took the Apollo 13 mission to this area called Fra Mauro. And I'll show you where that, well, we'll see that in a minute in here. But the Apollo 13 mission and 14 mission, our job was to do the first science on the moon. The other guys solve the operational problems of how do you do it. And we followed each mission, developed, went a little bit further, and did a little bit more than the guys before them. And so that was the way we developed things. Okay, here is Apollo 14 going to the launch pad. Now I want you to look at that. How many of you have been to Cape Kennedy? And perhaps you've been to the Apollo 5 museum out there. Well, those of you that haven't, take a look there, and let's see if you look, you can see the cars and you can see little humans there. They're so small here that it's hard to see them at all. The spacecraft standing from there to the top of it is 363 feet, which is a little over three football fields long. And it took all of that to get us onto the moon. But Werner von Braun and his team did a marvelous job of organizing and building that magnificent spacecraft. And it was one of a magnificent sight to see it at night with all the lights on it. Powerful, powerful thing. And those of you who haven't been to Cape Kennedy and seen the Saturn V Museum, I suggest you do so, because that's one of the last 3 Saturn Vs in existence, and it is in the museum. One of them is in the museum at Cape Kennedy. Okay, so we're going to launch and simulate a launch here, and and look at it getting up there like that. And what I want to show you is this. This is something that all of us who have flown into space from Cape Kennedy, I want you to look at that thin layer, get the light there, that thin layer of atmosphere around the Earth. That is our atmosphere. This picture is taken just as you go outside the atmosphere, and you can see it's just like a rind of an orange peel or an apple peel, and it's pretty darn thin, and that's what protects us from the solar, the gamma rays, all of the other particles in deep space that come in, and holds our oxygen. And I will point out to you that if you know anything about sustainability and photosynthesis, you'll know that our oxygen supply is being depleted here on Earth, and we have a problem with sustainability. And that's subject for another lecture, which we can do sometime. But we've got to start thinking about the fact that we humans are overrunning our planet with too many of us and using up on non-renewable resources, and we've got a problem on our hands. And on the way, after we get finished with the Saturn V and go into translunar injection, here's a model view of a lunar module on the front end of a command module. And that's the way it looks going on to the moon. And destination moon, we'll take a look at it here. I invite you to look. This is what you see when you look at a moon on the full night. And you see the dark, what the ancients call the Mare area, the blackened area. That is where lava flow from the inside of the moon came out in the first billion or so years and filled in the craters. As the craters were made by meteor and meteor impact and holes dug into the surface of the moon, they were subsequently filled up with lava rock and then pummeled for billions of years by meteor impact. So by the time we got there and looked at it, it isn't just lava rock, it's just fine powder, about like talcum powder, but it's on the front side here in those so-called Mare areas, and they're called Mare, which is a French word for sea. The early cartographers looking at the moon thought they were seas, and so they named them Mare. But obviously, we've only recently discovered that there may be a little bit of water on the moon, we just don't know how much. But certainly there's not a lot in this front side area. And I invite you also to look at the North Pole and the South Pole of the moon. You can see the ruggedness in 3D here. You can't really see the 3D looking at it here, but if you look at the polar regions, you can see how rugged it is. And our next slide here, as we take a look at it, we'll pull in just a minute. Here are our landing sites. Apollo 14, that arrow now points to where we landed, just a little bit to the left and down from the center point of the moon. And you can see the other was on here. There's 11 and 12 and ourselves, and 15, 16, and 17 up a little further higher latitudes. And this is what it looks like as you start to get close to it. This is a picture taken on the left side going out on the west side of the moon. And what you see, what I wanted to point out to you here, is these are the craters. These are big craters, a little smaller craters. Little smaller craters, there's craters of all size. Clear down to craters about the size of raindrops that a raindrop would make. Just virtually, it's pockmarked with craters all the way from the top to the bottom. And that's that rugged looking thing that we saw earlier. And this is what it looks like when you get close to it. And now we're going to move around to the other side. And a couple of things I want to point out here. As I said, this is Earthrise, and those of us who landed on the moon, we couldn't get to see a full moon, a full Earth like you saw in the first picture, because we had to have a phase of the moon such that we wanted to land in the early morning of moon time, so we could have the shadows of the sun. The sun could make the shadows of the spacecraft, and we could see our landing site much better that way. So here what you have is the backside of the moon. And I want you to notice that you don't have the black lava here on the backside. That's mostly on the front side, but you still have the craters of all sizes, and this is far more like dirt, although it's same sort of stuff that we haven't called dirt, but it doesn't have nearly as much of the lava rock on the back side as it does on the front side. And here is our landing site on the front side. And the little arrow right here, that's where we're supposed to land. This little formation right here is called Triplet Crater. That was one of our landmarks. So we come in right like this and land right in there. This was our target, and you'll see that a little bit later, on the second extravehicular period. That's called Cone Crater. And the geologists wanted us to pick up rocks and debris that came out of Cone Crater because it's about 800 feet deep, and they wanted to sample the rocks in the soil from deep in the moon. And the way it happens when a meteor hits like that, it turns the soil up and throws it out with you'll see a picture in a bit, the deepest stuff is right around the edge of the crater, and the shallow stuff is thrown clear out along here. And our job on the second EVA was to pick up samples all along here and bring them back for the geologists to look at. So here's a picture of our spacecraft. We're simulating a landing, we're bringing it right down. And behind, if we look behind, there is the flank of Cone Crater going up like that. And the Triplet Crater that you saw, that I pointed out, is right over here, is off the picture. But first things first, when we go to the moon, the first thing we did was set up the American flag and take our pictures with that. And so here you can see the shadow of the lunar module, or shadow of the lunar module. My partner, Alan Shepard, taking my picture by the moon. And that's the first thing we did, was take our respective pictures. And here is a picture with our traverse on the two days that we were working on the surface. Here again is where we landed. There's Cone Crater. Here's Triplet Crater. Out here in front of it is where we set up a science station on the first lunar vehicular EVA period, 4 hours out here. And then on the second day, we trudged up to the top of Cone Crater, gathering samples along the way and bringing them back. We had the first two-wheel vehicle on the moon. Now the guys after us had a motorized vehicle they could ride. We had something kind of like a golf cart that was made to carry our equipment, but we had to pull it by hand. And we pulled this all the way up to the top of Cone Crater. This is my partner, Alan Shepard. I took this picture. And if you'll look, you'll see on his helmet there a red stripe and a red stripe around his sleeves, because on the first two missions landing on the moon, we couldn't tell one astronaut from another. They both looked alike. So from that point on, our mission and further, the commander wore a red stripe, and those of us, the lunar module pilot, went without the red stripe. Here's the first tire tracks of our little two-wheel vehicle. You see in the background the lunar module. Whoop, I didn't mean to do that. Here we go. Here we go. There is the lunar module and the tire tracks from our little vehicle coming out here in front to where we set up the first station, the first science station, and with the telemetry. And you see here various pieces of science equipment, and there is the antenna beaming data back to Earth. And these are various pieces of equipment out here that we set up on that first EVA. And that station operated for 14 years after we left, sending data back to Earth. And I just gave a lecture in Alaska earlier this year, and in the back of it, they were interested in the lunar laser reflector, and it's right behind me there, and it's hard to see unless you're close. But what the lunar laser reflector does, you can send a laser beam to the moon, it comes back and it tells them within centimeters how far the moon is away. And they've discovered over the last 40 years that the moon has only moved a few meters further out from Earth than it was when we first started. And it's amazing, an amazingly stable orbit. But this lunar laser reflector is so good that it can measure the difference in the changes in the orbit within centimeters. Okay, on the next EVA, we're headed up Cone Crater. Here's a picture of me looking at the map, and very frankly, we had a little trouble not getting to the top of Cone Crater. We knew where we were going, but trouble in finding some of the waypoints that the geologists wanted us to stop and get data at, simply because it was like walking on the moon there was like walking in the desert with the sand dunes. One sand dune looks just about like the next one. And it's very easy to see our landmarks in the pictures that I showed you when taken from in space. But when you get down among them, it's a little different matter to find out just where you were. Now, it turns out we did what we were supposed to do, and you saw the track where they backtracked us in the red lines when I showed on the map here a bit earlier. But it wasn't quite as straight a line to the top of Cone Crater that we were trying to make, but we did it anyhow. And we're up close to the rim of Cone Crater right here, and what you see, this isn't quite as close as you'll see in a minute, but you see as we got close to the rim, the rocks get bigger and more numerous, because the heaviest, biggest rocks are the deepest and get thrown out onto the surface. The lunar module in this picture is right over the edge. See, there's an edge, and the lunar module is just out of sight down behind that, behind the rim of the crater. We go to the next one. One of the interesting things that we discovered was it wasn't all black and dark, that some of the deepest rock, these big rock, one of them was a white rock. And you see lying on here my geology hammer and a little sample bag that I used to put samples in. But this is the white rock. That was quite a surprise to find that color material there. And so the geologists definitely wanted us to sample that and bring it back for them so they could find out what in the world it was. It was just material like we have on here on Earth, but a lot more basalt visible on the moon itself. Okay. And so here we go back down to Antares. I am out adjusting the television camera, and you see the Antares right there, and my partner Alan Shepard, he's getting some equipment from over there. And in the background are the triplet craters that I pointed out to you when we landed. That was our major landmark as we came into land. And we had the television camera set up here, so some of you that were watching us back 40 years ago, almost 39 years ago, and saw us on television, it was from this camera right here that's right where I'm standing, about a couple of hundred feet away from the lunar module. Okay. And I will point this out to you, the solar wind collector. It's kind of interesting. This is kind of like a window shade. How do we get that? There we go. It's kind of like a window shade, and it's on a pole. And this is right behind on the left side of the lunar module. And that's a picture of me doing something, I don't know what it is. And the next picture is a television frame of my partner, and brought along a golf club to fit on the end of a piece of equipment that we had. And he whacked at 3 different golf balls and got one of them, the last one, and it popped it up into, you can see it right there, it popped up and landed into a crater right about there. Of course, in the telling of that, the story was it went miles and miles. And the next time, miles and miles and miles. And the time after that, miles and miles and miles and miles. And of course, since it really only went out just a little bit, unfortunately, because I'd like for it to go on further, I tossed that solar wind stake, that solar wind stake, after his golf ball. And if you see, there is the, where is this? The javelin is right there, and his golf ball is right there, about 4 inches behind it. So the javelin throw and a golf shot with the first Lunar Olympics, and one javelin throw, one golf shot, and I can say I won it by 4 inches. And I never let Ellen forget it. Okay, here we are going home. And what is happening here, the ascent engine is ignited. It's blown all the hold-down bolts and the pieces of fabric and metal out. And that's what it looks like in a television frame, just as we're lifting off. And what lifts off is this portion of the spacecraft here, comes shooting up. And the rest of it, the descent stage, remains on the surface and is still there today, as a matter of fact. So that is liftoff, and we're going home. And the next picture is of docking with the command module aboard the surface and around on the east side of it. And you can see the various craters, and you can tell this is the east side or close to the back side because it doesn't have the black lava to show it as the front side, like the front side does. And we're saying goodbye to Antares. This is what it looks like without its descent stage. And so we're leaving it there, and then shortly thereafter it gets crashed into the lunar surface and used as a hammer to ring the bell of the moon, because we did set up seismic instruments on the moon. And each mission, the lunar module was crashed into the surface when we were done with it at different points in the surface, so that it could send seismic waves from the point of impact to the various seismometers that we set up on each one of the landing stations. So nothing was wasted on these missions. They were all used for good science. And that's, and Antares is about to get smacked into the lunar surface there. Now, there's an interesting thing here. If you'll look at this one, this looks, this is on the, again, on the east side, and you'll see in here, I was talking about volcanism, this looks like a lava tube that's coming across that side of the moon, and that's caved in, and it carried lava and dumped them into these craters. And that's what that appears to be. It's an interesting phenomenon. And here is a crater that looks like it's got a lot of lava in it, but the rest of them don't. So it likely got filled by a lava tube that came to it, fell in there, and then the rest of them, this is far enough around on the east side or the west side, probably on the east side in this case, that not too many of the craters have the lava in them. Okay, homeward bound, and in the command module, and I'll let you read this. I'll read it to you. On the return trip home, going through 240,000 miles of space toward the stars and the planet from which I had come, I suddenly experienced the universe as intelligent, loving, and harmonious. I'm simulating this now because what we were doing, we were flying in the plane of the ecliptic, which contains the Earth, the Moon, and the Sun, and we were rotating to keep thermal balance on the spacecraft. What that allowed to have happen was every 2 minutes, every period of rotation, a picture of the Earth, the Moon, the Sun, and a 360-degree panorama of the heavens appeared in the spacecraft window. And ladies and gentlemen, that is awesome. It is awesome. And as you can see here, this looks very much like a Hubble picture. As a matter of fact, it is. Because what we could see with the naked eye in space, not quite as good as we can see with the Hubble, but close. And what I've tried to simulate here is using the background of some of the Hubble pictures and let you see the various planets and things move against the star background as we were coming home, and that's the way it looked to us. And this continued all the way home as we were, the 3 days that we were in orbit on the way home. And here's the sun, and then you saw the Earth and the moon and the stars. And we get closer to the Earth, and there's the moon. A simulation of all of that. And then we finally get home, and here's what it looks like, what it would look like if we could see the full Earth at that position. And we splashed down in the Pacific near Pago Pago. And got picked up, well, the frogmen came out and put supportive rings around the spacecraft so we didn't tip over while we got out. And helicopters came around and picked us up. And then all of us went into the carrier. The USS New Orleans was the carrier that picked us up. And here's a picture of the spacecraft being plucked out of the water and put into the spacecraft. And that, ladies and gentlemen, is the end of the mission. Okay. Very kind of you. Now, as long as the Worshipful Master will allow us, I'll take a few questions that you might have, if you would. The lady in the back.
I just want to ask you, I feel truthfully that the weather has changed.
I'm sorry, I'm having a little trouble.
I'm sorry. I feel that the weather has taken a complete turnover since this has happened, that we've gone to the moon and whatever. You know, our weather has changed. You know, our summers, our winters, our springs, our falls. I don't know if you understand what I'm saying.
No, what is your question? That
Was damage done to our weather because of the astronauts going up to the
No, had nothing to do with it. What it has to do with, we are probably, according to the evidence, that we're starting to enter a phase where there are a lot of solar flares starting to take place. And that happens about every 80 or 90 years. The last time it happened was back in the 20s, as I recall. Next year, we should have a lot more solar flares. But most of what is happening, I mean, we can't do much about what the sun's doing. It's going to do its thing. But what we can do is that one of these days, if we have time, get invited back, I'll do a PowerPoint for you on sustainability and show you all the things, not that the Earth, that the sun is doing, but in addition, what we are doing to our planet to cause these things to happen. So we don't have much control of what the sun is doing, but we do have a lot of control over what we do. And very short story, very brief, our population has gone from under 2 billion at the beginning of the 20th century to over 6.5 billion at this point, and headed for 9 billion by the middle of the century. And we are utilizing resources, non-renewable resources, at an unsustainable rate. And the evidence of that is very, very strong. And we've got to start doing something about it very, very quickly. I've been lecturing on that particular subject now for 35 years because it's been obvious what was happening in all this period. But our going to the moon doesn't have anything to do with the climate that changes we're experiencing now. Go ahead, sir. Yeah.
What are your thoughts on where the future of the space program should take us and suppose?
Okay. Good question. What's the future of the space program? Well, right now, our president has all he can handle trying to get the economy back moving again. And it's not a bad move that he suggested that the private sector get far more involved in space exploration. And that's a good move. Now, we haven't really stopped. We're not really going to stop with the nations doing it. I'm sure that's going to come back. But right now, we've got to get our economy back going. And then we can go on. We will, I'm sure, go back to the moon and do more investigation in due course. And we will go on to Mars as the next planet. And that will be in our not too distant future. I often, since I'm asked this question quite frequently, my standard answer about going on to Mars is yes, we'll go on to Mars in due course. But when we go to Mars and look at this tiny little speck back here at Earth, because it'll just be a tiny little speck like that from the distance of Mars. It'll sound kind of foolish to say I came from the United States or Canada or Britain or Russia or Germany or Israel. No, we came from Earth, and we're not ready to do that yet. We've got to get our act together as a civilization. Now, and I'll just depart with one little statement. We already have been visited. There are aliens here among us, and it goes back centuries that they've been observing us and letting us do our thing. But we have to, I'll be with you in just a minute, we have to get our act together, and we have to become a spacefaring civilization also in due course. Our sun only, I say a couple of billion, only has a couple of billion years left. It's by the time, it's not going to affect us in our lifetime, but it's going to affect our children. And we've got to get ourselves off this planet and moving toward being a universal civilization in due course. And I've written papers that have been published in scientific journals that says if we don't blow ourselves up with our stupidities before then, we might be able to do that by the end of this century. But the real question is, can we stop our warlike tendencies and killing each other over whose God is the best God and whose boundaries are encroaching on other boundaries and things like that? And so most of the evidence that we need to look at is how do we shift the awareness of ourselves and our consciousness toward learning to cooperate with each other instead of being in conflict with each other. Your point, your question.
Do you think the next people to land on the moon will be the Chinese?
Well, the Chinese are angling in that direction. They need to, or they will do it. Well, let's look at it in this way. The moon is a lot closer than Mars. And when you're going to do testing and testing your equipment and testing your procedures, and it's a lot easier to do it in a near body than it is to do it in a Martian body. And with the power, the technology we have now, chemical propulsion, the moon is roughly 6 to 7 months away at the best. And that's not good enough. So a Mars mission, just to have an exploratory mission, is at least a year long. To get there, do anything, come back. And the fact is that the Martian orbit is twice as far out as ours, and it's 2 years around. Their year is 2 of our years. And so we'd have to time that just right so that we launch for Mars when it's coming toward us, spend a little time and get off of it before it gets too far away on going the other way. So there's a lot of work to be done, but we must do it in due course. Go ahead, young man.
How come when you're in space and you see pictures, everything's black, you see no stars?
I'm sorry, a little louder, please.
How come when you see pictures of space, like inside the spacecraft, you see it all black, you don't see any stars?
Okay. Well, let me ask you this. Let's get it home. Can you see stars in the daylight?
No.
Okay, they haven't gone away, they're out there. So the reason you can't see the brightness of the heavens or see stars in the daytime is because your eyeballs shut down, contract like the lens of a camera, and camera shut down. You have to squeeze the exposure down on a camera to take any pictures, and that precludes getting pictures of the stars from the moon or on the lunar surface. However, if, in our spacecraft on the lunar surface, if we look through our little telescope to help align our navigation platform, you can see stars through there. Or if you were to take a roll of a tissue paper, a center roll, and put it up there to your eyes to exclude the ambient light and the reflected light, you can see the stars. But you can't just looking at it with your naked eye. Okay? Yes, please go.
How long did you train on the lunar landing module, and how did it feel when you actually landed? Did it feel like you're training?
Well, that's what we convinced ourselves, that the real thing was an awfully good simulation. But I think I spent, I think all of us spent on the lunar module that were our responsibilities of the lunar module. We got somewhere like 1,000 hours of lunar module time, of simulator time. So we had it down pretty good. Go.
You mentioned something about a higher civilization viewing our own. Did you believe in that before you entered the space program, and was there anything in the space program that changed your opinion?
No, as a matter of fact, I wasn't that knowledgeable about it before I went into the space program, except I grew up in Roswell, New Mexico. And as I said earlier in my talk, my people were agri people. They were ranchers, and we had ranches, farms, and farmer dealerships. And the Pecos Valley where we lived, Roswell, Artesia, Carlsbad, that whole area, there weren't more than 50,000 people within a couple hundred miles back in those days. So it wasn't hard to know most everybody. And so when I came back from the moon, and I went back to see friends, and my family had gone by that time. When I went back to the Roswell area to visit friends and to give a few lectures and so forth, there's a highway named after me, it's something like that. At public gatherings, I'd have some folks tug at my sleeve and say, "Can we talk to you?" I said, "Sure, what do you want to talk about?" Well, we were here, these were what I call the old timers. They were there in 1947, or they were the children of the old timers. And they wanted to tell their story because they had been shushed up under penalty, painful penalty, if they talked about what went on at that point in time. And these were folks who had been involved, like the undertaker who provided coffins for the deceased alien bodies, and sheriff's people who had helped control traffic. And also, we had a close friend who was an Air Force major that wasn't an office mate of Jesse Marcel, who was the first officer on the crash site, but who knew him. And all of these people, they thought, and because they couldn't tell anybody else, they thought maybe I was a safe bet to tell their story to. So I heard a lot of stories about this. And then a few years ago, it's been 13, 14 years ago now, I went to the Pentagon and got an audience with the Joint Chiefs of Staff Intelligence Committee, headed by a Vice Admiral at that point in time, and told him my story. And long story short, we got it confirmed. He didn't confirm it at that point, but there has been a cover-up. Now, it's all not necessarily government, because there's a lot more to it than that. I will remind you that when President Eisenhower retired from the presidency, in his retirement statement, he said, "Beware the military-industrial complex." And this is what he was talking about. This a lot of training, and it was just, that was part of life. But the whole point was, as I said, when I first made my decision coming back on a carrier from the Pacific, that a new phase of human activity had just been entered into. And we were explorers. We wanted to find out what that was and be a part of it. So we realized there were risks, but the rewards were worth the risks, and all of us were willing to take it. You got a point.
Yeah, I heard you say that you were on the moon for about a little over 30 hours. I was just wondering if you guys slept.
I'm sorry, try that again.
I heard you say you were on the moon for a little over 30 hours.
Yeah.
And I was wondering if you guys slept while you were there.
Oh, yeah. We had 2 periods out, so we had a period in the middle where we went back in and got some sleep. It was kind of fitful sleep, I'll have to admit. And had some food and rested and got ourselves ready to go out. The first period was just to set up the science station out in front of the spacecraft, when you saw pictures of that. And the second period was to do our trek up Cone Crater and do a geology trek and gather the samples and bring them back. Yes, please.
Yeah, Dr. Mitchell, I was curious, I have 2 questions actually. Did you get a chance to bring any moon rock back? And
Beg your pardon?
any moon rock, did you get a chance to bring any moon rock back? And what type of camera equipment did you use to shoot those pictures
Okay.
on the lunar surface?
Okay. Yes, we brought back over 95 pounds of lunar material, the most at any at that time. The guys after us had heavier equipment, had longer stay period, had improved equipment, so they could do a little more than we could do, but we did what we could with our equipment. And the camera, we were each carrying, if you look closely, we each had a Hasselblad mounted on the front, on a bracket, so we could just click it and point. We point our body and click. And then on the little rover, or rather the little transporter that we had a Mauer sequence camera. There you could put it on sequence and you could take 3 frames a second, 5 frames a second, or all up to about 20 frames a second. So it clicked away while we were taking pictures, while we were doing our traverse. And we had another one of those in the spacecraft window taking pictures as we landed. So we had pretty good pictures, yeah.
What was the temperature?
Well, it depends on what time of day it was. We particularly landed, you see, the moon has very extreme ranges of temperature. At a lunar night, it gets down to almost absolute zero on the dark side of the moon. And it gets up to well over 200 degrees on the front side when it's light. So that was the reason in our choosing landing sites and trajectories to get to the moon. We wanted to land early morning lunar time right where we were for 2 reasons. It was cool, and secondly, as we landed, the sun would be behind us and we could see the shadow of the spacecraft as we approached. We could watch our landing trajectory much better that way. So, and for our mission and the next mission or so after us, we wanted to be off the moon by the time that the sun was roughly 10 o'clock our time in the sky. Could it get too hot from that point on? And also the guys after us had a little better equipment that they could handle a little more oxygen and water, and so they could last on it a little longer than we could. Go ahead.
When you were out in space, were you able to see any extraterrestrial crafts or anything
No,
like that?
none of us really saw anything up through the Apollo program. Now, I've talked to all of those guys, but I don't, I think during the shuttle program, there were some reports of UFO encounters during the shuttle program. And certainly as pilots on the ground, whether pilots in the Air Force or in the Navy, I didn't personally have such an encounter, but I know many of my colleagues did. And they were debriefed and told to shut up and don't talk about it, and et cetera, et cetera. So we quit reporting them after about the first 10, 15 years of it. Yes, sir. Then you, sir.
Our interaction with extraterrestrials?
From extraterrestrial, no.
Or anything along those lines?
No, there may have been some, but most of the technologies we have today were invented right here. And although I happen to know the book by Colonel Corso, he claims quite a bit of back engineering. Well, there may have been a little bit, but there hadn't been much. And I do point out to you young people walking around with your new cameras and telephones, you have more computing power in those cameras and telephones than we had in the spacecraft going to the moon. Go ahead, sir.
Just a quick question. What do you attribute the secrecy around Area 51 in that situation? What was the point of the huge secrecy?
Yeah, well, that's a good question that we don't really have the final answer to. It started off, I'll give you a little history here. It started off with the powers that be, both in England and here, were afraid that people would panic with alien visitation. Well, after the Orson Welles story in the 1938 of a Martian invasion, some strange things happened, and it scared the bejesus out of a lot of people. Now, what did take place? Wave at me when you're ready to want me to quit. Thank you. After the Roswell incident in July of 1947, since I was there at the time, and I have a copy of the newspaper actually, on the day after this was reported, it came out in the Roswell Daily Record that an alien craft had crashed. And the next day it came out, oh, that was a mistake, it was a weather balloon. Now, President Truman at that point was confronted with a real dilemma. The OSS, which was the intelligence community during World War II, had been disbanded. The CIA had not yet been commissioned. The U.S. Army Air Corps had been separated from the Army and had just become the U.S. Air Force. And so nobody knew what the hell was going on anywhere that was in charge. And what President Truman did was created a special advisory committee of military, political, and science people, university people, and it was called the Military and Joint Intelligence Committee, and abbreviated MAGIC 12. Now, there's a lot of debate. I mean, there's a lot of people deny that even existed. Well, it does exist, and it did exist. And it's come down through the ages, through the 60-some years here. But what President Truman gave them, he gave them authority to manage this problem. And that was the beginning. And the Magic 12 grew to quite a few more people. And although it had military people, and had university people, and had political people, but all very respectable people in those days. But it expanded out. And then the National Security Act of 1947 really gave them some power to handle all of this. And a level of secrecy was imposed. And unfortunately, over the next few years, this group expanded their power and was able to shut down a lot of things. And a lot more people got involved, and corporations got involved. And so what we have going forward for the next 60 years is one hell of a mess. And it's still, slowly we're starting to break it out, but it's not coming out yet. Yes, sir, go ahead.
Dr. Mitchell, would you like to comment on the noetic sciences?
Let me come over and ask.
The noetic sciences, the institute that Libby founded, or some of that?
Okay, well, what the gentleman's asking about is a nonprofit organization, research organization I founded after coming back from the moon. And the reason, a little background here, the reason with the epiphany that was touched upon there was so profound for me, that I realized that since we were the first generation of spacefarers from Earth, and that forever humans had been asking the questions, who are we, how do we get here, where are we going, what's this really all about? And we in science, we knew that our answers to it were incomplete, that we didn't really know an awful lot about what was out there. And that we realized that our cultural answers to who are we, how do we get here, where we're going, coming out of our various cultures, mostly out of our religions, was archaic and perhaps flawed also. And so as a burgeoning spacefaring civilization, we're the first generation. And I was had been trained, of course, at Harvard and MIT in astronomy and these subject matters. I realized that perhaps we needed to start asking these questions all over again from a new point of view. And a little history here. If you go back to the end of the 17th century, and the great thinkers of that period, the beginning of the Industrial Revolution, and a particular member of the church, intelligentsia, René Descartes, wrote a paper at that period that said that body, mind, physicality, spirituality belonged to two different realms of reality that didn't interact. Now that served a very noble purpose of that point in time. It got the Inquisition of the period off the backs of the intellectuals. So they quit burning them at the stake for disagreeing with the church. However, it also caused as long as they didn't start talking about mind and consciousness and spiritual things. So what that caused to happen was that science arose at that point, at the beginning of the Industrial Revolution, but it rose as strictly a materialist concept without any notion, as long as it stayed away from mind and consciousness, that they were safe, couldn't get burned at the stake. But the problem is, we've gone all the way to the 20th century. At the end of the 19th century, Max Planck, a German scientist, along with Einstein and a few of the others at that point, Max Planck discovered black body radiation, which is the idea that all matter, our bodies, those chairs, the ceiling, everything else, is radiating energy away all the time. And that was picked up by Einstein because they were trying to solve the problem of what is the speed of light and how does it come through space. So this was the beginning of what in modern times we call quantum mechanics. And it was finally formalized by the 1920s, but it clearly showed that Descartes' dualism, that body, mind, physicality, spirituality don't interact, was wrong, just flawed. However, academic community for most of the 20th century has clung to Cartesian dualism, it's called, and refused to look at how mind and body interact. So my experience in space was, we got to do something about that. And I formed my Institute of Noetic Sciences to break down, forget the Cartesian dualism, let's figure out what consciousness is. And that's what noetics was all about. And we now realize from the studies we've done that our awareness and our consciousness is firmly rooted in the quantum world. Now, do we all know all the answers? No, we don't. We've broken the code a little bit, but we haven't really pulled it all together yet. There's a lot of work to do. And I have just recently, a few years ago, started a new research foundation to take off from where noetics is working on the studies of consciousness to go into more of the hard sciences, the physics and the biology, bringing a new concept called quantum holography, which demonstrates that Max Planck's black body radiation is coherent and carries information in a quantum way, which is powerful stuff. So that's what we're doing. Yes, sir.
I've got actually two questions for you. One, I'm just curious. When we talk about the other astronauts that they saw or didn't see anything, on Apollo 11, they saw something that they thought, they sent a cryptic message back to Houston, trying to figure out what something was that was floating outside there. Did they ever figure out what that was?
Yeah.
First question.
The best guess right now, it was the S4B final stage.
That was. My second question is, I know it's about a 25,000 mile an hour escape velocity to get yourselves towards the moon. But that's a little bit fast once you get into the moon to get into an orbit. So how did you slow down? It took you 300 feet of fuel to get to that speed. How did you slow down to get into
Well,
orbit?
you got a lot less weight when you get out there.
Yeah.
And we had enough fuel in the command module. As we went into lunar orbit, we turned around and we slowed it down so it would go into orbit. Now, we also remember that there's a point between the Earth and the moon where the gravitational pulls become equal. And you go up and then you start to fall into the lunar orbit, you start to pick up speed again. You're slowing down all the time as you go out a little bit. But then as you get into the lunar orbit, you start to fall down into that gravitational well. So you turn around on the backside and point the rocket to where you're going and slow it down a little bit, and you go right into lunar orbit.
So what is about the speed of a lunar orbit?
Let's see, I haven't computed it in so long in the feet per second, but an orbit around the Earth is 90 minutes. An orbit around the moon is 2 hours. Okay, so, and it's a quarter the size of Earth. You can figure it out, you can work on that and figure it out.
I'll start working on it immediately.
Huh? I could sit down with a piece of paper and tell you in a little while, but not off the top of my head.
I'm gonna take just one more question I'm gonna take, and then I think I'm gonna cut it off.
Okay, good.
It's been great, I appreciate it.
Who gets the last question? Go ahead.
How do you address people who want to tell you that we never went to the moon?
Oh, that's a very simple one. Very simple one. Do you think the Soviets would let us get away with that since we were on a race to the moon with the Soviets? Not on your life.
I'm glad I allowed one more question. That is my pet peeve.
Thank you. What are we going to do now?
I got a little gift for you.
Oh,
Sit
you
if
do?
you'd like. You've been standing a long time. On behalf of Boynton Lodge, I would like to present you with first a set of cufflinks from our lodge. And this is one of those things
That'll
you
go
put in your
along very
pocket. They're
nicely, won't
emblems,
it?
Boynton Lodge 236. And the reason we're giving this to you is because we expect you to wear it every time you come and visit here.
Okay, I'll do that.
And we expect you to come visit a lot.
Thank you, sir.
Thank you for
very much.
coming. On behalf of the lodge.
Thank you.
Thank
Been
you.
a wonderful audience.
Thank you so much for coming. I think it was a lot of fun tonight. At this time, I would like to ask all the stewards that are here, and any of the brothers that are not with small children, if you guys could go out and into the kitchen and help prepare those food. We have a little bit of food out there, and I didn't expect this big of a crowd, so hopefully we have enough food. But there were about 15 pizzas and about 20 something had it before. But go out and enjoy yourselves. Just give the stewards about a minute or so to get set up, and we'll get on out there.
Are you going to think you're going to be able to do a lodge meeting tonight?
What's that? No, we're not going to do a meeting tonight.
Oh, my.
Thank you so much.
Oh, well, thank you. It's a pleasure.
I can't. People that tell me that that never landed on the moon, I say the same thing. You ask the Russians, and you know, after the cover up of 500,000 people.
That's right.
It's so aggravating to me.
There's that one.
Got another one on you?
We gave them enough time. Thanks everybody. Thank you everybody for coming.
I think that was it.
Food right next door.
I think that's it, isn't it? Here, put those in your pocket. Oh, I've got the big one. Put those in your pocket.
Oh, all right.
Here's the big one. I'll let you're probably going to end up taking a lot of pictures and signing things.
Never mind.
Is that the whole thing?
That's it.
Amazing. Amazing talk.
Thank you, Dr. Mitchell, for coming to Boynton Lodge 236. We appreciate your visit.
Thank you, Mitchell.
Thank you very much.
You bet.
Now, do you want a copy of this thing? I'll send you a copy, no problem.
Are you? Yeah.
Yeah,
You're going to put it on a DVD, a CD? Or
Yeah, whatever you want.
Yeah, just
You want to ask me
Okay.
questions? You want me to take you in the other room?
Action.
Brother Bowman, what did you think about the lecture from Dr. Mitchell this evening?
It was very intriguing. It was actually the third opportunity I've seen for his adventure in space, and I'm going to be going home and looking up Roswell 1947 and checking out on the internet when I get home.
Thank you.
You're welcome.
Right Worshipful District Deputy Grand... Let's start again. Right Worshipful District Deputy Grand Master Wayne Hansen. What did you think of our speaker this evening?
Incredible. I wish I understood it all. A lot of it went over my head, but it was incredible. What an opportunity. How many people can say that they sat there, they shook his hand? The DeMolays had an opportunity to meet a senior DeMolay. What a deal. It was incredible. You did a fantastic job.
Thank you. I appreciate that.
Ricky,
Talk to the mic. Ready? Go.
Ricky, tomorrow when you go to school, you're going to tell the kids that you met Edgar Mitchell. You got to ask him a question.
Of course, I'm gonna tell my social studies teacher at first, and my science teacher, and anybody who has to do with space, and my friends. It was awesome.
Pretty cool, huh?
Yeah.
Great.
Thank you. Thank you. Here's a guest of our lodge.